That would be Brigadier General retired Clint Anderson. His apologies, he was called away about 30 minutes ago on some urgent business, and we were hoping he'd be back in time, but he didn't quite make it. So David Thomas from Mistral Incorporated. We are a US small business incorporated in Delaware, with our principal offices in the DC metro area. Mistral analyzes capability gaps in the US tactical force and finds solutions for those problems. So, water generation, the need. In late 2012, the Army identified a challenging area focused on reducing the logistics footprint by 75%. Water from air technology can assist in achieving this critical goal. The challenge then was reaffirmed by CASCOM in 2014 in their Force 2025 QFR, their quarterly future review. Producing water from air at the point of use will reduce the number of trucks on the road carrying water, reducing cost, reducing the number of trucks in a convoy, will reduce the number of soldiers or contractors required, and naturally reducing the backhaul of empty water containers. That need continued, and here you see in 2014 the CASCOM top capability need for that force. Alternative sources of water meet the demand at the point of need. Reduce demand. Increase endurance and efficiency, reliability and maintainability. All common themes when looking at the logistics chain. We believe our solution is a solution that solves this. The capability needs analysis identified those two gaps. Those two gaps at the bottom of your screen. The first one being the package to generate water and providing a routine supply to dispense it. So, water management technology. This is the operational view, number one. And this was taken, the first one here in the extra small category, the 50 packs. And here you see on the left-hand side of your screen where they talk about future reuse, where we have one water truck every 4 days. And as we go down the line here, when we look at future water reuse and water from air, now we've got a fuel truck every 27 days. And then at the bottom, future with reuse and man-portable purification, we've got a fuel truck every year. The second area here deals with a 300 pack, and here that water reduction, the future with reuse on the left-hand side, continues that trend. So we've discussed the need. Now let's discuss the solution. The Water Gen 350, independent atmospheric water generation system, producing 96 gallons of water per day, based on an average temperature and relative humidity of 77% Fahrenheit. Now this is a science, not an art. There's no magic. We are governed by Mother Nature, shall we say, so it's fairly predictable how much water we can generate in a given environment. Energy efficiency is enhanced. And we see at the bottom, we just need 5.8 kilowatt hours. Operating temperature 45 up to 115 F. And there's the dimensions of the Water Gen 350 coming in at about 5.5 by 4.5 by 4.5 feet. The form factor can be adjusted. So let's talk about some numbers. Let's get to some efficiencies. Efficiency improvements. The efficiency under normal conditions, 25 degrees C, a little less than 80 degrees Fahrenheit. There you see our initial water generation devices were coming in at approximately 6 kilowatt hours per gallon. The first water gen units came in at 3.2 kilowatt hours per gallon. Water Gen 250G comes in under 2 kilowatts a gallon, and our Water Gen 350 is now producing a gallon of water for a little over a kilowatt. That means we've got 11 gallons of potable water for about a gallon of fuel, depending on how you want to measure the metric, depending on where you are in the logistics chain, excuse me. So let me give you a status, a program update. The U.S. Army REF, Rapid Equipping Force, purchased 5 of these systems for their use in Central America. The systems are currently located in various locations within CONUS. One system's in Fort Belvoir, we've got a couple over at Aberdeen, and we've got 2 systems with PACOM. The UK MOD selected the Gen 350 to participate in water analysis research. Extensive evaluations in both laboratory and field settings. The Gen 350 was also selected by the UK MOD to participate in a NATO, a NATO capable logistician 213 in Slovakia, and the systems performed very well. And the UK MOD recently purchased additional Gen 350 systems. So, in summary, atmospheric water generation is capable of assisting the Army in mitigating its goal to reduce the logistics footprint. The amount of water produced with the atmospheric water generation technologies is predictable. Once again, it's a science, not an art. Is AWG suitable for all locations? Definitely not. The answer is no. Not every tool is effective in every location. But many of the Army's systems are not as fully effective in every location. An example here given by my boss was envision an M1 tank being deployed to a location inundated with swamps, and my boss was a tanker. So the bottom line is that we believe at Mistral that the Army can make significant headway through the utilization of AWG. Our Gen 350 is available today. It's TRL-9, and we're ready to assist the Army in providing a path to meeting its goal. So with that, I'd like to invite you to visit our booth number 932 in the South Hall, if you'd like to speak to the subject matter expert. And please come and visit us, and I'll take some questions if you have any.
Dave.
Oh, hello there, sir.
How are you today?
Very well, thank you.
Good. Had a couple of questions for you. One question, you had mentioned some of the places that they had been deployed. Can you say anything about specific missions that they've been used in, or operational experience with them?
No, I can't personally give any of the specific missions. I do know that one area where we pursued an evaluation, we were invited to NIE in 2014. This was in El Paso, Texas, where the climatology is not conducive to high volume of water production. This was our measurement, and our water generation was very predictable. It was less than a gallon a day. The US Marine Corps, I do know, also in 2014, did some evaluations in Hawaii, the Philippines, and Thailand. And I'm told they had superb results, but I can't comment on exactly how much the production was.
The system uses power to operate.
Correct.
Is there any metric you might be able to offer up that gives you an idea of the efficiency of the system from a power to water production ratio? And do you know any comparisons, say, against rope use? They're pretty energy-intensive systems.
Well, the two metrics I can give, one against power and one against fuel. The one against the power is we currently produce, on this model I was referring to, a gallon for a little over a kilowatt. 1.17 kilowatts gives us a gallon of water. On the fuel side, it's about 11 gallons for 1 gallon of fuel.
And the water, when you're condensing it out of the atmosphere, is it are there any issues with microbes, other stuff getting in there, or is there further treatment that's necessary after production?
No, the water is potable coming out of the machine. It's drinkable. Yes. Actually, I believe at the convention here last year we had one in our booth and were offering cool chilled water to the folks as they walked by. Most of them were looking for coffee, but we were able to satisfy some of the officers with a cool glass of water.
Are there any other questions?
Well, thank you very much, ladies and gentlemen.